The sum and difference of two functions are defined as follows. If f and g are two functions, the sum function, denoted by f plus g, is defined as f plus g of x equals f of x plus g of x. Similarly, the difference function, denoted by f minus g, is defined by f minus g of x equals f of x minus g of x. The sum or difference of two functions is a function whose domain is the set of all real numbers that are in the domain of both f and g. Okay, so here's two functions. What is f of x? What's f of x? What kind of function? A line. What about g of x? Square root. So we are going to figure out a new function by adding the two together. It looks really bad, but it's not bad at all. All we're going to take is f of x. Well, actually, maybe I'll show my steps here. You don't have to show this after you understand what's going on. This is just equal to f of x plus g of x, right? So this is going to be 1/2 x plus the square root of x plus 4. Bam! That's all we have to do. So we're just adding the two functions together. Do we have to graph this? If we had to graph, just relax about the graphing. So you would not know how to graph a line and a square root together. However, all you're doing when you're graphing it is adding the y values. So you'll see it's not as bad as you think. Okay, so f minus g of x. Again, that's the same thing as f of x subtract g of x. So that would be 1/2 x subtract the square root of x plus 4. Yes? Does everybody remember how to find f of 12? You plug 12 as the input, so you get 1/2 times 12, which is 6. Again, you don't have to show all these steps. I'm just showing my steps for you guys. What about g of 12? So that would be the square root of 12 plus 4, which is the square root of 16, which is 4. Again, you could kind of done mental math and got that. So what I want to demonstrate now is if they wanted to find f of x plus g of x of 12, because you've already found it, technically it should just be 6 plus 4. But you could have also used your new function there, right? And found f plus g of 12 into that, and I got 1/2 of 12 plus 12 plus 4. Either way, I'm going to get 6 plus 4 is 10. Does everybody see that? Okay, so f minus g of 12. So that would be 6 minus 4, which is 2, and I don't need to demonstrate it up there. And then if I wanted to find f plus g of minus 6, so then it's up to you how you want to do it. If you want to find f of negative 6 first, g of negative 6 second, and then add them together, it's up to you. Yeah, but honestly, you're doing it kind of at the same time, right? So, so what do you want to do? Like, honestly, you could probably do it as mental math. Negative 6 goes in there. What's 1/2 of negative 6? Negative 3, and then you're adding whatever you get g of negative 6 to be. So g of negative 6 goes in there. You get the square root of negative 2. So what happens then? It's undefined. So let's go back to what our definition was up here, and I kind of glazed over it. It's the domain is all real numbers that are in the domain of f and g. So if I actually looked at this, the domain of my x here is x is an element of reals, right? So I could have plugged anything into my f. However, what is the domain here? No, not greater than 0. Yeah, greater than or equal to -4. So that's precisely why the -6 didn't work, right? So from the very get-go, because I knew you couldn't find a value for g of x for -6, I didn't even have to find f. Because if one is not defined in one of the functions, you can't add something together that doesn't exist to something else. Does that make sense to you? So that's the thing here, is we could have just said like undefined right away because of the fact that this is not defined here. Okay, so the domain of the combined functions formed by the sum or difference of the two functions is the domain restricted to the individual functions. The range of the combined functions can be determined using its graph. So now we're going to graph it. Yay. I like yay rather than oh. Okay, so we're gonna individually graph them, and then I'll show you it's not hard at all, okay? So if you have different colored pens, I recommend different colored pens. So I'm gonna do f of x in blue. So that's a point on 0, up 1/2, yes? Everybody knows how to graph a line, right? F of x. Is everybody good with my line? Let's take some points here. What is that? 1, 2, 3, 4. Let's start at -4. It's at -2. And at -2, it's at -1. At 0, it's at 0. At 2, it's at 1. And at 4, it's at 2. So I'm going to take those points. I'm going to make it very noticeable. There? Yes? Okay. I'm going to go green now. How do I graph the square root of x plus 4? G of x equals the square root of x plus 4. It's a base square root graph that got shifted to the left. 1, 2, 3, 4. And then we're going to use our pattern of 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 1, 2. And then we're going to go, let's do one more. Let's do, I don't know, 9, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay. Yes? So at -4, it's at 0. Yes? At -2, well, it's at the square root of 2, so I'll just leave it as a square root of 2. At 0, it's at 2. At 2, it's at the square root of 6. And at 4, oh, it's the square root of 8. This didn't work out so great for me, did it? That's okay. So what we're going to do here now is we're going to add the two values of the function together. Does everybody understand that f of x is the output, which is the y? G of x is the output, which is the y. So what are we doing? We're adding the two y values together. So I'm going to do this in red. -2 plus 0, -2. But we're not going to do a table of values. It takes too much time, right? I'm just doing this on the first couple examples, but you're welcome to do a table of values if it makes it easier for yourself. So you look at the heights, right? This is essentially what we're going to do. We're looking at the heights and we're going to add them together. So what's -2 and 0? -2. Yes? Oh, I didn't label my green graph. Let me just label my green graph. Okay. So then, next one. I'm going to take -1 and add root 2 to it. So this is -1 plus root 2. So root 2 is like 1.4, yes. And I'm going to add a -1 to it, so it's going to be about 0.4. But you can see the height here, right? If you're at sorry, I'm right here. -1, and then I'm going to add this to it. So does everybody see this square will negate that square, and you're just that square, which is about 0.4, right? Yes? Sure. 0 and 2, of course. The height of 0 and 2 is going to be 2. So do you see it's kind of curving like that? Yes? 1 and root 6. What's root 6 about? Root 6 is about 1 point what? 2.2, 2.3. Well, we can see visually it's just a little bit past, right? So essentially we're adding a 1 to that, so it's just going to be, say, like that. More? Yeah? Yeah? Okay, and then 2 plus root 8. 2 plus root 8, I would, root 8 is almost 3, right? And visually it looks like almost 3. And then I'm adding 2 to it, so you can just go 2 squares up, 1, 2, I'm at there. Do you see? And so now what's going to happen at the end of this? I could keep on going, and what's going to happen? Do I have an end point, I guess is what I'm asking? No, it's going to have an arrow, yes. That's a great question. So the question is, does the other side have an end point? Yes. So, and that's the big, big idea here is you can only add two things together where they both exist. And because the g of x doesn't exist left of -4, it is an endpoint. This graph only starts where they're both together, right? So this is f plus g. Okay, how do we do there? So we're all nervous about graphing this function, but it's not so bad, is it? Right? It's just adding. And honestly, I took some points that were kind of like, I would just pick whole number ones to add, and you get the gist of the graph, right? Okay, so now we're going to subtract this. So we're going to do a quick sketch again. Let's not fill in the table this time. Try to do it without the table. So we have 0, 0, up 1 over 2. Yes? Okay, so there we go. There is my f of x. And then my other one, I'll do in green, is my g of x, which is 1, 2, 3, root 4. And that's 5, 6, 7, 8, 9, 3. So there's my g of x. Okay, so I'll wait a second. You get your two graphs on there, and now we're going to subtract. Now, adding doesn't matter which order you add. However, subtracting is huge for order. Why? Because the minus is going with the g of x, right? Not the f of x. So you can't just arbitrarily subtract the two values. You have to take the f and subtract g. Okay? So that is the only mistake I usually see is on subtracting. People lose track of which ones they're subtracting when they don't have a table, right? So, do you want me to write my table?
Yes.
Oh, okay. Let's have our table back. So, -4, -2, -2, -1, 0, 0. 2, 1, 4, 2. And then on the green, we got goofy stuff. This is a 0. -2, it's at, well, I'll have to figure it out. So that would be root 2, right? This is 2. And then at 2, it's root 6. What do you mean, how do I know? I plug it in, man. The equation says root of x plus 4. So whatever your x value is, just plug her in, plug her in. So then 4 goes in, I get root 8. Okay, so the question is, am I picking random? Yes and no. I'm trying to pick numbers that will be nice to add and subtract. However, with this square root, it's not so easy to pick both, as you can see, whole numbers there, right? So I could have designed my picking of random numbers designed to those whole number points, right? But then I have halves. Would it have been easier to add halves and subtract halves? Do you guys want to do it that way this time? No, honestly, like it might be easier to then. Oh, you wrote it in pen already. So, but do you see what I'm saying? If I would have picked so this height of 3, and then this is a height of 2.5, right? That might be easier to subtract than square root. You know what I'm saying? Okay, doesn't matter. We'll keep going. So the key here is when you pick a point, they have to be the same x value that you subtract. You can't just pick an x value here and an x value here and subtract them arbitrarily. No, it has to be the same x point, which is why the table is kind of nice. But anyways, so we're going to take our f value and subtract our g value. So that's still -2. Does everybody see that? This subtract this is still this, yes? So now I have -1 and I'm subtracting root 2. So root 2 is, yeah, like it's -1.4. So then I'll have a -2.4 approximately, right? So anyways, here's that. So I'm taking that value and subtracting that. So do you see? There it is right there. You can use your fingers there. 0 subtract 2 is, of course, -2. So there's -2. Ooh, what's going on here? 1 subtract root 6. So again, this was approximately -1 subtract 1.4. So this was, we said, was -1 subtract, what's root 6? Say 2.2? Again, it's approximate. So this is a -3.2. So then I'm right here, right?
Wait, it's not -1.
Oh, it's +1. Yes, thank you. So -1.2. Yeah, because I was going to say I'm matching it up and it doesn't make sense here. So then I'm at, so if this is, say, right here, I'm subtracting that. I'll be like right there. Yeah? No, that's not right. A little higher than that. -1.2. See about there. Yeah. Why did that not look right? That, and I'm subtracting that. Anyways, so to subtract root 8. No, I'm graphing the point 2, and then this is approximately -1.2, right? So I'm graphing to -1.2.
Oh, because you're not going right from the x-axis, you're going from the point.
I'm only looking at the y values. I'm not going x left or right. I'm just taking those.
Like the point where like at 1, going to be like 1.2 down from that, or is it down from 0?
Well, I'm taking the value of 1 and subtracting root 6, right? It doesn't work as great when I'm like I guess what I'm saying, I was taking this gap and I should have been taking that gap to get to there, right? You know what I mean? It's the height of 1 and then I'm subtracting this height. So that's what makes it go down to there, right? Yeah? So again, sometimes it's easier to do the chart. It's up to you. So this is approximately 2 subtract, what, 2.8? So that'd be about 0.8 roughly. So again, if I look at this, it's this, subtract this height, right? So this height gets subtracted, and I will get about 0.8 there. So you can see it kind of goes like that, kind of goofy. Yeah. Yeah, so you got to think about this for a second. If I take a line and add a line to get it together, what will I get? Another line. If I take a curve and add a line to it, you'll get another curve. So there's no way you can make a curve into a straight line, right? You know what I'm saying? So, okay. Is f plus g the same graph as g plus f? Yes. Order for addition doesn't matter. Would you get the same graph if you went f minus g versus g minus f? If not, is there a relationship between them? So no. Order for subtraction is important. Okay, so let's order for addition doesn't matter. Okay, so let's look back at here. Is there a relationship between f minus g and g minus f? So if I did -2 subtract 0, 0 subtract -2, that would be 2. Okay, let's see if it works the other way. -1 subtract this versus this subtract that. Is it the same number with a different sign? This subtract this. This subtract this. This subtract this. So what is the relationship then? The height, essentially what's happening here is this would be up here. This would be up there. This would be up there. So what is that relationship? Over the x-axis, yes. It ends up being a reflection over x-axis. Okay, example 2. The x-intercept of f of x is 4 and the x-intercept of g of x is 4. Michael concludes that the x-intercept of f of x and g of x is 8. Do you agree with Michael? Justify. This was an exam question. Okay, so I see no. Why? No, that's not the reason why it's no. It's not. Okay, so I heard the correct answer. Can you repeat it? Yeah, you're supposed to be adding the y values together. So this person didn't understand. So we don't agree. So when we add f of x plus g of x together, we are adding y values, not x values together. So my question then to you is, would the answer be 0 then? Would Michael be correct if he said 0? I hear yes. Does anybody want to say no?
I already said no once. No.
I'm sorry? No. You can have a graph here. Like let's pretend there's a graph here, and one of the x-intercepts is, it could be a line going through 4, right? There's 4. There's my f graph, right? And then f plus, and g of x could be going like that way, yes? And it's at 4. Yeah? So nobody wanted to say no? Okay. I was trying to trick you, but yeah. So you can see visually, and it doesn't have to be lines, it could be curves or whatever, but they're all at the same x value. Now, if the x-intercept was 4 and the x-intercept of g of x was 5, you couldn't add it together, right? The only reason why we could add it together because they're both 4s, and 0 makes 0. So if you want, you could say f plus g would equal 0. Correct answer. Okay, the domain of f of x is less than or equal to 2. The domain of g of x is greater than or equal to -7. State the domain of f of x and g of x and justify your answer. Does anybody think they know? It would be the value between. So for some reason, this wasn't asked on the exam, and so many students had problems with it. So that's why I started putting it on here. So if you don't understand what the heck is going on here, you could just pretend we have a graph that starts at 2 and goes less. Who cares? It's going this way, right? There's my f graph. And the g of x is starting, you know, at -7. 1, 2, 3, 4, 5, 6, 7. It's starting, say, I'm going to put it down here, and then going like this, right? There's my g graph. Yeah? So does everybody see? You can't add things together unless they both exist. So you can only add from where it starts. They both start and they both end, right? So the domain of f of x and g of x then would be, x has to be between -7 and 2. Or you could write it as -7 and 2 like this. Yes? Technically this should be x is an element of reals, right? Yep. Okay. Moving on. Yes, if you use set notation. Okay, moving on. We're going to subtract the 2. A lot of the times when they give you these made-up graphs, they will actually plop it onto that to help you. Have you done any of the exams yet where you've noticed that? It's very helpful, actually.
I like how they tell you that.
Yeah. Okay, so I'm going to give you a second to do this one. So given the graphs of f of x and g of x, sketch g of x minus f of x. Yeah, so it's only going to start at -4. So 1, 2, 3, 4. So at -4, f is at -1. And g at -4, 1, 2, 3, 4, it's at 4. Does everybody see that? So now 4 subtract -1 is g subtract f. So that would be 5, yes? So -4, 5. 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 1, 2, 3, 4, 5. Yes? Does everybody understand why I picked -4? Yeah, there's no graph past -4 for f, so there's no point picking anything there. Okay, so it's up to you if you want to pick more, but this is anytime it changes direction, that's a huge point. Anytime it changes through an axis, you should pick that point too. So I'm going to pick -2 there because that's a change of point there. So g is, what is that? 1, 2, 3, 4, 5, 6. So 6, and at -2, it's at 2. So 6. Do you notice also in my chart, because I'm going g minus f, I have g first. Highly recommend that because it's very easy just to subtract the 2 in the row, right? So at -2, I'm at 4. 1, 2, 3, 4. And I highly also recommend connect as you go. Okay, again, if you're adding or subtracting a line and a line, you're going to get a line. So when you connect them, connect it as a line. Okay, so now this is going to be at 0, is another change of whatever. So g is 1, 2, 3, 4, and f is 2, 3, 4, 5. So we get -1. Is that what you got? Yeah. So then it goes like that. And it's going to end at 2, right? So at 2, it's at 1, 2, 3, 4 for G. And at 2, it's at 1, 2, 3, 4, 5, 6, 7, 8, yes? So negative 4. So at 2, it's at negative 4. 1, 2, 3, 4. So is that what you got? What do you think of this? You wouldn't know how to do it unless I showed you, but once I show you, it's pretty easy, right? Yeah. Okay. Let's try this one. F of x minus g of x. F of x minus g of x. No, it's not curved. A line and a line, when you add, is just another line, right? Yeah, yeah, yeah. Yeah, and so these are all lines, essentially, right?
Right.
One time on the exam, they asked if f of x is this graph and g of x minus f of x is this graph, find g of x. Yeah, so it's kind of like you're working backwards. Or what you could do is you can work the other way, right? No. Oh, that is what we're doing. Hey, oh my gosh. Woo. That's what we're doing here. Good thing I'm recording this. Okay. Oh my gosh. Okay, so I'm going to put the next column then f minus g. Does everybody understand that f of x can be written as f? Next year in calculus, they don't write f of x, they just write f. G of x, they just write g. Because then when we get into derivatives, it's just f prime, right? Have you heard of what I'm talking about? Okay, that's all good. First semester, it's all derivatives, so. Alrighty. Okay, so at 1, f is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4. That is probably why I put it on there. Okay, so 5 subtract what gives me 4? 1. So 1, 1. Does everybody see how I got that? And then at 2, 1, 2, 3. And at 2, it's at 2. What do you think it is? 1? Yep. Yep. Okay, at 3. 1, 2, 3, 4, 5, 6. And 2 again. So what's that going to be? 4? No. 1, 2, 3, 4. Alrighty. And then at 4, which is my endpoint, right? 2, 3, 4. That's a 2 again, and this is a 1, 2, 3, 4, 5, 6 again. Look at that. Craziness, hey?